I said, if we feel pretty good about these warm-up problems, we're going to be in really, really good shape for the lesson today. So I'll look at this last one. With these fractions, we want to see what number goes into both 6 and 12. But we know 6 goes into both. So we're left with 1, left with 2. We have x on top, x on bottom. And y is left over. So we have 1 over 2y. Let's see. We divided by 3, 3, 4, and 1. Good. We're left with x because there's no x that we can cancel out or anything like that. And then we just have 12x over 3. So 12 divided by 3 gives us 4x. Nice job. On these factoring ones, you guys did a really good job. Remember, we have to have numbers where the last multiply together to give us our c value and add together to give us the b value. So that's where, like we have negative 24 on the end, we know we're going to have a positive and a negative. That's the only way to multiply together and get a negative here. But we have to be a little careful with where we put the 6 and the 4 to make sure that they would add to give us a positive 2. So nice job on whoever did that one. 6 times 3 gives us 18. 6 plus 3 gives us 9. 2 times negative 10 is negative 20. 2 minus 10 is negative 8. Good job. Negative 3 times negative 1 is positive 3. And negative 3 minus 1 is negative 4. Awesome. I think those are all right on. Do you guys have any questions on any of these? Or once we, even if we got it maybe wrong or had a hard time when we did it the first time, once we see the right answer, does it kind of come back to us? We haven't factored for a while. Okay. So today, we are going to take a detour from graphing today, and we're going to take expressions that look like this, our rational expressions, and we're going to look to try to simplify them and factor them. So, who can remind me from yesterday what a rational expression is? What is like the technical definition? Or even we talked about rational expression is in the form y equals something over something. What was that fraction made up of? What? So you're thinking of inverse variation, which I like that we're thinking to that, but that's not what I'm getting at. What did you say, Joe? A polynomial over a polynomial. Remember, a polynomial could just mean like 3x. That would just be a monomial. Polynomial could also mean like x squared plus 2x plus 1. That would be like a trinomial. So the definition of a rational expression, well, first off, a rational, well, yeah, I guess rational expression works. It's a polynomial over a polynomial. Today we're going to have some review, a couple terms, examples, practice. All right, nothing too extensive today. Now, a lot of times I don't use my vocabulary great with this, but there is a difference between an expression and an equation. Today we're looking at an expression. What is the difference between an equation and an expression? Does anyone know? Or have an idea? What's the difference?
Expressions show a graph.
They can, but that's not technically the difference. They both can be graphed. I like that you're throwing stuff out there. Abby, what do you think?
Maybe an expression is more like a visual reference.
You guys are thinking way too deep, but I like that you're putting stuff out there. Amari?
No, an expression is something you simplify and the equation is something you solve.
That's closer. Yeah, that's closer. The difference is an expression does not have an equal sign. So an expression could just look like this. That's a 3. An expression will look like this, while an equation does have an equal sign. Today, we are not looking at equations, and this isn't like a main point for today. This is just to have some good vocabulary. Today we are not looking at equations. We're not dealing with equal signs. We're going to be simplifying expressions. So they're going to look like this, but we're going to try to simplify them. So in other words, we're not solving for just one thing. We're simplifying an expression. Here's the first term that we are looking at. You don't have to write this whole thing down, maybe a couple bullet points or jot a note, but this is just to make you aware. When we are simplifying these rational expressions, we say that it is in simplest form when the numerator and denominator have no common factors except for 1. So like in our warm-up, we knew that like this was in, well, that's not good. This was in simplest form because we couldn't cancel anything else out, right? 1 is in simplest form. 2y is in simplest form. We don't have like another y up here that we can cross out. Everything is factored to the max. And the mathy way to say that would be that they don't have a common denominator except for 1. So that's the technical. Oh, that's not good. There you go. That's the technical like way to look at it. But pretty much what we're saying is that something is in simplest form if we can't cancel anything out, if we can't factor anything out. And that's what we're going to be working on today, writing things in simplest form. So, here would be our first example, and this is a lot like the warm-up. Simplify each rational expression if possible, and this time we want to state the excluded value. So a little bit of stuff from yesterday. We're not graphing, we're just simplifying and giving the excluded value. So if we look at letter A, what is the common number that both 12 and 2 have? Common multiple, 2. So 12 divided by 2, it could be 6. 2 divided by 2 leaves me just with 1. And we have x squared left over. Now, like our definition of simplest form, the only common factor that 6 and x squared have is 1, so we're in simplest form. Now, what would our excluded value be? 0. If x equals 0, we'd be in trouble. That would be undefined. Letter B. What can we do in letter B to try to simplify? If anything. Well, remember, we can't solve for anything because we don't have an equal sign. We're just trying to simplify some stuff. Is there anything that we can simplify in letter B? The factor? Yes, Abby?
Yeah, factor. Like, divide with I don't know. I'm just taking a wild guess.
That's okay. Any other wild guesses? So, there is nothing that we can do to factor this. This is already in simplest form. The reason that this is on our example is because what a lot of people try to do is they say, hey, we've got an n and an n, we can cancel those out, we're left with just 1/8. Why can we not do that? Like, very basic reason. What's wrong? What do we have right here? Well, yeah, we're adding, right? We can't be canceling stuff out when we're adding. The only time we can cancel stuff out is when they're being multiplied. This was n times 8, then yeah, we'd be able to cancel. We can get rid of those, but we cannot cancel if we have just the addition involved there. So this is in simplest form. What is our excluded value? -8. Last one. Let's look at the whole numbers first. 3 and 6. Do those have any common multiples? 3. So that would leave us with y squared over y times y minus 7.
Could you divide it by 3y?
Yes. Yep. If you want to do it all in one step, you could. I'm taking it in 2 steps just to show a little bit more work. But kind of what Leighton was getting at. What else can we cancel out? The y, right? We have 2 y's on top. We have 1 y on the bottom. So we can get rid of the 1 here. Get rid of the squared, and we're left with this y over y minus 7. Again, this is in simplest form. We cannot cancel out this top y and that bottom y because it's
y minus 7, right? It's not y times 7. Questions on those? Or is that, we've looked over problems like this before in algebra. This is maybe a little bit more. Oh, what's our excluded value? Sorry, that's one more important thing. What else? 0. We need to make sure when we look at our excluded values that we look at the original expression that it gave us. So both 7 because of here and 0 because of this 6y. We think I have to find that line. Good. Again, we looked at these before. We haven't stated excluded values with problems like this. Like in the last couple months, we've done stuff like this. We have not stated excluded values, but we've simplified these before. So why don't you guys go ahead and do 1, 2, and 3 on that practice. Should be the second page of your class kit. I'm trying to stay up front because hopefully virtual students will be able to hear me now. We'll see. But after people being virtual for a trimester and a half now, I can't believe you're the first person to say that you couldn't hear me. Maybe they just didn't want to mess up class. I thought that was just the way it was. Right, virtual students? Are you guys watching the videos? We'll find out. Maya, you better be watching. Send me an email if you're watching. And give me an update. Tell me when you're coming back. I used ClassKick for geometry this morning, and they liked the new stickers that we made yesterday. So I'll show you guys today. Don't worry. But so good job, guys. We need the Mario one today with a good saying. I think "Let's go" is a good one. Or "Let's go." After you get your practice problems done, that would be great. We'll go about 1 more minute. I just want you to get rolling on these. If you finish them up after the lesson, that's okay. Oh, sweet. We only have 1 more example slide and then 1 more practice slide, and then we're donezo. Good job, everyone. Thank you. Look at that after the lesson. All right, let's keep moving. Yeah, I know you might not have finished all 3 of those, but you got enough of a head start to be able to finish this after the lesson. So now we're simplifying a little bit more complex problems here. First, when we look at this first one, we want to try to, just like, well, I guess we didn't exactly explicitly do it those ones earlier, but what we want to try to do is write these in a different form. In this form, we can't cancel anything out, right? Like it's all being added or subtracted, so we can't just start canceling things on our own. We need to write both of these polynomials in a different form so that we can see what similar terms they might have and start to cancel some things out. So that top one, how can we write that in a different form? What would that form be? What can we do that we did with one? We can factor it. Good. So we could rewrite it as C and C. Let's see, we need a negative 12, so that means we're going to have a plus and a minus, right? Because a positive times a negative is a negative. And then we need a positive 1 when they're added together. So I'm going to go 4 and 3. Now if I factor the bottom. negative 20 and negative 1. 4 and negative 5. Wait, plus 4 minus, yeah, 4 and negative 5. Plus 4 minus 5. Now that we have things factored out, do we see any similar terms between the bottom and the top? Yeah, they both have a c plus 4, c plus 4. So what we're allowed to do, just like we did up here with canceling y's and canceling other variables and stuff, we are allowed to cancel out the c plus 4 and the c plus 4. And that leaves us with c minus 3 over c minus 5. I know we didn't do anything like this in Algebra B. We haven't so far in C. I'm guessing you guys didn't do anything even close to this in Algebra A. That would not be right. Well, we did factoring in Algebra B, right?
Let's say.
So, I don't think there's any way you would have looked at anything like this in A. Right. Now, this other example, we're going to skip because that one's more about rewriting. Well, check it. Let's look at it. How are we feeling about this stuff so far? Feeling good? Most of our problems, or a majority of our problems, will look like this and look like this. The one that we're going to look at here is kind of a special situation where we're thinking outside of the box a little bit. So I'm going to show it, but don't get totally caught up on this one right now. We'll get it eventually, but don't get fully caught up on it. With this question, we have 1 minus x squared over z squared over z minus 1. What they're looking for us to do is write it in this way. We can just move things around. If you guys are writing this in your notes, I would just label this like special situation or something like that. Now, the next step that they would be looking for us to do is factor a negative number, or negative 1, out of the top. And even if you don't write this down, it's okay. Now, technically, we don't do it, but technically we can rewrite 1 as 1 squared. Now, this is where there is some good review built in, but when we've had something where it's a polynomial like this, and both a binomial, and both numbers are squared, how have we rewritten that in the past? Do you guys remember? We have rewritten it as z minus 1, z plus 1. Now, what can we cancel out? Yeah, we have a z minus 1 and a z minus 1. So we are left with a negative z plus 1, well, just a negative z plus 1. So, I think you guys can follow those steps, right? Those are all algebra rules and things that you've seen before, but it's probably would be pretty tough to think of all that on your own. Is that fair to say? You can follow the steps, but you're thinking, I would not have thought to do all that on my own. So, like I said, that is a special situation, and if there would be one like that in an assessment, I give you a pretty good heads up. It would probably be a repeat problem, but I do just want to show that. Let's go back because I forgot with this first problem that we looked at, because we need to write our excluded values. What would be the excluded values for this first one? One more time? So I see where you're coming from. one thing to point out that we haven't talked about a lot is that if the top equals 0, then that's okay. If we have 0 divided by something, then that's fine. That just equals 0. The reason the bottom can't equal 0 is because that is undefined. Like that mathematically doesn't work. We cannot divide by 0. So you are correct with x not equal 5. What else can x or z, no, c not equal? 5 is one thing. What's the other? C could equal 0. Look here, even though we crossed c plus 4 out, it's still our original, just rewritten. If c equals 0, we'd have 4 times negative 5, so we'd be okay. The other value I'm looking for is negative 4. So even though we crossed it out here, it still gives us one of our excluded values. It still helps us see what that denominator is not. So my bad for missing that. We did that problem the first time. Go ahead, and why don't you guys just do number 5? It's a little bit different than the example that we looked at, but why don't you just do number 5? Raise your hand on class kick.